The main point of a for each loop is that it allows you to execute something for each item in a collection. Say I have a spread of points, and for each of the points I want to draw a circle. I can use a for each loop for that. There are two ways to create a for each loop now. One is you can use the node browser, type for each, choose the italic one, and then take whatever nodes you want to have inside of the loop and press space while moving them inside. You notice how you can also drag them out again by pressing space. So that's one way. Another way is you can select whatever nodes you want to have in a for each loop and right-click, surround with for each. So for each of the points in the spread we want to draw a circle. So we start a link from here, and you notice you cannot directly connect to the circle's position input. This is because the output of the grid points is a spread of vector 2, and the circle only takes a single vector. So what we have to do is we have to enter the for each loop via the Splicer bar, the one with the Splicer symbol. And now we can connect, because you notice the Splicer has actually two sides. It has an inner side and an outer side. On the outer side it has the spread. On the inner side it only gives us one vector at a time. So now we can connect to the circle. As we surrounded the circle with the for each loop, what happened is that the connection to the renderer got lost. Why is that? As we can see, the circle returns a layer and the renderer takes a layer. But what happens as we start a link, you see, is we cannot directly connect. We can never directly make a connection from a pin inside of a loop to anything outside of a loop. So again, we have to use the Splicer bar to exit the loop. And now we have the same situation as we had on the input splicer, is that the splicer has two sides. On the inside it has a single layer, but on the outside it has a spread of layer. And now that explains a spread of layer cannot be connected to the layer input of the renderer. So what we need now is a node that takes a spread of layers and turns them into a single layer. That is the group spectral. Let's say we have another spread, a random spread in this case, and this should be the random sizes of all the circles that we have. So we start a link from here. Again, we cannot directly connect to the radius, so we enter again via the splicer. Now we can connect to the radius input. But what happened is that suddenly we only see one circle. Why is that? Because the for each loop always decides the number of its iterations from the smallest spread count of its input spreads. So in this case, one spread with 16 inputs, another spread with one input. So the smallest number is taken, we only have one iteration of the loop. So as I increase this number, you notice how the number of circles that we see increases. So I set it to 16 here so that we have exactly the same number as the grid points. So that's the very basic functionality of a for each loop. And now there are three more things you can know about it. If we double click inside of the loop, we see we have some special pins available here. We have a break, we have an index, and we have a keep. So let's start with the index. The index returns us for every iteration a unique index starting from 0. So let's try to just draw those. So this clearly shows us that the index pin returns a different value for each of the iterations. And in this particular case, it allows us to visualize the order of the points in this spread. We see the grid points returns the points in an order where the first one is at the bottom left, and the last point in the spread is at the top right corner. Next to the break output. With the break output, you can force to stop the execution of the loop at any time, regardless of the number of loops that would be defined by the number of input items. So this is a simple boolean, and I can set it to true at any point during the looping to stop the execution. So an example would be use the greater operation connected to the index, and then say if the index is greater than a given value, then stop the execution. In this case, I set it to 5. So if the index is greater than 5, it has already drawn 7, in this case, circles with indices going from 0 to 6. You can also see this down here. The spread that is returned from the loop now has only 7 items. If I set it to 11, it has drawn 13 items, as we can see here. And to show you the final feature, the keep, I'm going to remove the break again. I'm using the keep now. The keep allows us to specify for each of the iterations whether the result of it should be kept in the output spread or not. So if I, for example, say only keep the result if the index is odd, then we get this result. We now have actually only 8, meaning half of the circles in the output spread. And this is also what we see here. We only see the odd indices. One last thing, you can obviously also have multiple output splicers. So for example, I could easily show me the indices here by passing them out and visualizing them in an I/O box, and you see it's also only showing the odd indices. Now there is only one thing left I haven't shown you about the ForEach loop, and that is the accumulator bar, but this will be a separate video.